Alright folks, Tonto Bob here.
So where the air comes in, this clean
Around there.
Yeah, just a second.
So Ben, what have we witnessed today?
Taco Bell.
Alright guys, so today we're going to be talking about the basics of wood gasification. What you're looking at now is a diagram of a wood gasifier, a typical imbert style wood gasifier. It might look similar if you've been looking at the FEMA Handbook or just been researching it online. I'm going to go through the general, way the wood gasifier functions. I'm going to go in basically two parts. The first part being a general description of, the function and the parts of the main unit here. I'm just going to call this the main unit throughout. It's not the entire system that you'll need if you want to run an engine on wood or whatever. But anyway, then I'll go into more specifics like the temperatures needed to crack the tar properly, the composition of syngas, types of fuel you can use, and throughout that second part, I'll be relating back to this diagram a lot when talking about, cleaning of the gas and things like that. So, with all that said, I'm going to show you some references really quick. These channels right here are very, very good channels to check out if you are trying to build a wood gasifier or understand the function. Doc Decox on YouTube, he builds a gasifier with beautiful craftsmanship. It works really well on a very large horsepower engine. Like I said, it's probably the cleanest unit I've seen on YouTube. Flash001 USA, he builds pretty much an everyman's gasifier. It's also an invert style gasifier, but he makes some changes to it, makes it simpler to build, and he has a really good step-by-step video of how to copy his design, and it's pretty much what I based my design off of. I didn't copy him, but I based it off of him when I was building mine. And you can see my my build in my series called I believe it's called Wood Gasifier Build for Dummies or something like that. Then going down, CNC machining is fun. I didn't watch his videos until, sadly, after I'd built my unit, but his channel is loaded with very good information on, a victory gasifier that he built and restored, and I believe he's been off the grid since like 1990 or something like that, 1999, I can't remember. He's been off the grid for more than 10 years, so he knows his stuff when it comes to talking about wood gasifiers. And then another reference you can go to is the, all-time guide of wood gasifier builders. It's called the Handbook of Biomass Downdraft Gasifier Engine Systems. It's normally referred to as the FEMA Manual or the FEMA Handbook. It's available in PDF form. Just Google FEMA Handbook of, wood gasifiers, and it'll be the first thing that comes up probably. So with all that said, let me get right into it. Let's get into the explanation of what this thing is and how it works. Alright, so what is wood gasification? Well, wood gasification is pretty simple. It's where you partially combust wood and then harvest the gases that aren't combusted to run in an engine. So getting a little bit more into detail, basically let me explain this diagram right here to you. If you've seen like the FEMA Handbook or just looked it up online or watched other videos, you've probably seen similar diagrams before. But I'll go over it anyway. This is the hopper and drying zone. You just fill this full of wood. That's where your wood waits to get gasified. Right here is the pyrolysis zone. That's where the wood gasification happens. Right here is the combustion zone. That's where the fire takes place to make the wood gasification happen. And right here is the biochar zone. That is just a place for the heat to kind of thermally crack the gas. So, and I'll get into what that all means later. Then your gas comes up from the suction of the engine and then goes through a series of filters and things like that in order to be ready to go into the engine. But I'm not going to go over that today because that's a little bit more in-depth, and this is just about the main unit of the gasifier. So what you're looking at here, all the blue lines, pretty much just this represents the air from the outside world. The pink and blue represents the wood gas. Already explained the zones. So basically, getting a little bit more into depth, you fill this about right here with wood up to the top of the combustion zone, right where the air is going to come in because you need oxygen in order to have a fire. Then you light it, then you fill the rest of the way up with wood. So what happens then? Well, since this is on fire down here and it's retaining a lot of heat because it's inside of a container, the heat kind of just goes up into the hopper, where this first part right here, the pyrolysis zone, or pyrolysis zone, however you pronounce it, the wood in that zone starts to decompose. It decomposes and starts to turn into charcoal and things, and the tar and the gases from the wood decomposing come down through here through the combustion zone, where the tar is thermally cracked into turning it into more fuel for you to use, and it comes down here to the biochar zone, where it's continued to be thermally cracked. The tar can stick on the biochar, which is no longer on fire because the oxygen from the outside world is already being burned up here, in theory anyway. So thermal cracking continues to happen through the biochar zone, and then the gas, which is now hopefully completely thermally cracked, goes up through your system and into your engine. I guess the simplest way to explain it before I get into the more details is that when you have a normal campfire, it's about, it's not temperature enough to, I guess, crack all the tar and stuff like that, but when you have a normal campfire, the gases from the heat of the fire rise above the wood and then mix with oxygen and then combust. All you're doing, the only difference here is you have a lack of oxygen to your fuel. So your fuel down here creates a lot of heat, the gases come off the other fuel around it, and instead of combusting right there because they're mixed with air, they come through the system, and then the fire, I guess, is moved into the engine. It's as simple as that. You're just moving the burnable gases from where the fire normally is over into the engine after a little bit of refining. So I guess I'm going to get into the more specifics, the numbers, all that good stuff, thermal cracking and everything like that. So stick around for that, and thanks for watching. Alright, so this is going to be like the second part, getting into detail on this thing. So the main point of a gasifier, this is an imbert style gasifier, I should say, is to maximize the efficiency, maximize the amount of fuel that you can get out of your wood and make it as clean as possible. You do that through thermal cracking. Now, imbert style gasifiers, downdraft gasifiers in general, are typically the hottest gasifiers in the combustion zone, allowing for the best thermal cracking. And all thermal cracking means is basically thermal decomposition of the tars that come out of the gas or biofuel, or they come out of the wood, I mean, or biofuel that you're using. So, as you know, you may not know that wood creates tar when burned. It just gets burned up when you have a campfire or whatever. But you know how they always say, like, smoking coats along with tar. Same deal. If you burn wood, it coats everything in tar. Tar comes out of it. So then that tar isn't just going to get like stuck in your system. Hopefully tar can get decomposed down into usable, burnable gas for your engine. That way you can get maximum efficiency, maximum, I guess, gas production out of your wood. So what do you need to do in order to thermally crack your tar? Basically, on an imbert style system, the heat is all kind of contained in here in order to, I guess, allow it to get as hot as possible. And the magic number of, I guess, 2,000 is what everyone always says, is about the number, 2,000 Fahrenheit, is about what you need to completely crack the tar. It's best to try to get it about 2,200 Fahrenheit, but just do as best as possible in order to get your tar cracked. Because if you don't get that tar cracked, for one, you're wasting good, usable fuel. You're losing efficiency if you don't crack your tar into burnable fuel. And then second off, if that tar makes it all the way to the engine and gets put in the engine, it'll stick your valves, it'll stick your cylinder, I guess, walls and everything like that, and your engine will die after after like one running of it. Not to mention it'll gunk up all your filter medium. It'll gunk up just your entire everything that comes out after it comes out of your main unit. So it's really important to get all that tar cracked in here, and you can do that by building your system to the right specifications. I have the right specifications in my first video of my building a Gasifier for Dummies series. I have the chart right here. You can look at it. So basically, you build every gasifier to your horsepower of engine, and you can look into more of that later. That's not really part of this. This is the basics. All right. So moving down from the combustion zone to the biochar zone, what is this even here for? Isn't that hot enough to crack your tar and things like that? Well, pretty much the biochar zone is just there as just more area for your tar and things to get sucked through and slowed down a little bit. Just more area for heat to contact that tar and thermally crack it. So basically, in my opinion, the bigger biochar zone you have, the better. Just more room for your gas to get cleaned and more efficiency, hopefully, as long as it's not so big that it's hard to draw your suction through, and then it should be fine. So that's about all you need to say about the biochar zone. And now moving along to what the heck is syngas? After you cracked your tar and all that stuff, after it's all gone through here and it's about ready to go in your engine, what is it? Well, syngas is approximately, depending on what type of fuel you use, 20% hydrogen, 20% carbon monoxide, 5% methane, 50% nitrogen, 5% other gases. Like I said, that's not solid numbers at all. Depends on what fuel you're using. And you normally mix it to a 50-50 air to fuel ratio before you get it into your engine. So, what kind of fuels, what kind of fuels can you use? You can use wood, I've used bark, I've tried to use corn and it worked for a little bit before it got clogged up. You can even use plastic and things like that, but it needs to be able to create charcoal also, so it needs to be mixed with some sort of wood. You can use peach pits, cherry pits, olive pits, rice hulls. Some big gasifiers can use low BTU fuels like rice hulls and corn cobs and things like that. Pretty much anything that will create charcoal when burned with a lack of oxygen is usable fuel. But you really do want to stay above 6,000 BTUs per pound. Wood is obviously, depending on what type of wood, hardwood is normally around 8,000 BTUs per pound at 20 to 15% moisture content. So what else? What is the next item of business here? So basically, the easiest way I can explain this, like I said, is instead of having the fire down here and all your gases and usable things being burned up, you just pretty much move all the burnable gases into the engine. You just don't allow them to get burned up right there. They got to come through all these zones down here and get thermally cracked. Get thermally cracked as they pass through here. Get thermally cracked as they pass through the biochar zone, and then go into your engine to get cleaned. It's about as simple as that. Don't want this video to be too long, so if you have any comments, suggestions, corrections, I might have been wrong about some of my information. I've only built one gasifier, or I built two, but only had one that worked. Please drop them in the comments below. If they're coherent enough, then I will definitely respond to them, and I might make changes to this video if I'm wrong about something. So with all that said, please comment, rate, subscribe. It really helps out, and thank you for watching.